Okay, we're going to go on and find some binomial probabilities. Now, you're given this formula, and I'm going to show you one example of using it. But most of the time, including for this example, you can just use your calculator, so I'll show you that too. Okay, so the formula says that the probability from a binomial, you need an n and a p, which you automatically get when you set it up. So for this one here, we don't know what the situation is, but the first number is always n, and the second number is always p. So in the formula, when I see an n, it's going to be 8, and when I see a p, it's going to be a quarter. And then we want the probability of x being little x. So the outcome little x is going to be what goes here and what goes here. Okay, so all I need to know is how to get n choose x, this part of the formula, and that's done using your calculator. If you look carefully at your divided by button, you can see it says NCR on it, so that's how we get values of that. So using the formula, just this once, to find probability of x being 6, this is our x, so copying the formula, the probability of x being 6 will be n choose x will be 8 choose 6, and then we need to do times p, which is a quarter, to the power of what's x, 6, and then we need to do 1 minus a quarter, which is 3/4, to the power of n minus x, and n is 8 and x is 6, so that's 8 minus 6, which is 2. So on my calculator, I'd do 8 choose, so that's shift and divide 2, so there's my 8 choose 2. Sorry, it wasn't 8 choose 2, it was 8 choose 6 I should have done. 8 choose 6, and then I just do brackets. Brackets can be very important, divided by 4, so a quarter to the power of 6 times a bracket of 3 divided by 4, close brackets, to the power of 2, press equals, and it tells me I've got a maths error. What have I done wrong? 8 choose, well, maybe I need to put the 8 choose 6 bits in brackets with the times after it. It might be trying to do a different order of operations. So that looks a bit better. Yes, so it gives me that scary looking fractional answer, which is a probability of 0.0038845 to four significant figures. Okay, but I can do better than that. Okay, just one final point. It says that this formula is given in the formula book. Actually, if you look in the formula book, it writes this n choose x thing as n choose x like that, a bit as if it was a column vector, which it's not. But if you are going to use the formula book, then beware of this. It does appear like that. Right, okay, let's do this one the other way. So I've got to go into menu 7 for distributions. Now, the first way of doing it is by using binomial PD, but we can always sidestep binomial PD. And the reason why you might want to avoid ever using it is that binomial CD, which is the one that you're going to be using a lot, looks almost identical while you're using it. But binomial PD is quite nice. I'm going to do variable here. So I can put in values of x and n and p. So I've already got those. I've got n is 8 and p is a quarter and x is 6. But I've got to put them in the correct order. So x first is 6 and n was 8 and p was 0.25. And I press equals again, and I get that exact same answer of 0.0038845, same as I got before. Okay, now I'll show you also how to get this using binomial CD. Now this is going to be a pattern that you can use for every single example you do, so it is going to be a bit longer for this one, but it's worth getting into the habit. So the outcomes on this binomial, obviously the biggest I can get is 8, and the smallest I can get, I'm counting successors, well I could get no successors if everything's a failure. So they range from 0 to 8, and I'm interested in 6, and it's always a good idea to do the value on either side of the one you're most interested in, but I can put ... for these ones that I've missed out here. So I want to get 6, I don't want to get 5 or 0, I don't want any of the others. So how can I capture 6? Well, the way binomial CD works is it works out the combined probability of all the outcomes from 0 up to the one you're interested in. So if I draw a box from 0 that includes the value I want, then that will be binomial CD with an input value of 6. But of course I just want 6, I don't want these with crosses on, so I'm going to draw another box around the ones that I need to get rid of. And that shows me to get the probability of equaling 6, I can do the probability of x being anything up to 6, which I can write like that. So that's the probability of all of these values. I need to take away, I need to get rid of the probability of x being anything up to and including 5. So I can write that for my method. And now in binomial CD, I'm going to do 7, and now I need to find the next page, which is binomial CD 2, and it does say binomial CD at the top, but otherwise you can see this looks just exactly the same as binomial PD did, and in fact it's got the same values in, and in fact I do want that value 6. So when I now press equals, I get this number. This is 0.9996185. Okay, that's the probability of being all outcomes up to and including the 6. So I'm certainly not done yet. I need to go back and change that to a 5. So if I now change that to a 5, I get the probability that I need to take away, and that is 0.9957733. And if I subtract these two values, guess what? I'm going to get the 0.003845 again. So this is the same answer. We've got it 3 ways now, and I've shown you the different methods that you can use.